Welcome to this talk entitled A Speed of Light Deterministic Industrial Internet of Things. This talk is based on a paper in the IEEE Communications magazine, June 2016. My name is Ted Szymanski, and I'm a professor in electrical and computer engineering in Canada. The Internet has used an inefficient best-effort communication paradigm for the last 40 years. Most people would be surprised at how inefficient the current Internet is. The current Internet suffers from excessive delays, jitters, and packet loss rates. Delays as large as several hundred milliseconds can occur. The current Internet is over-provisioned to improve performance. The industry has overbuilt the network, typically by a factor of 2 times or more, to improve its performance. The problem is over-provisioning is very inefficient. Energy costs, measured in billions of dollars per year, go up in smoke. Similarly, capital costs, measured in billions of dollars per year, go up in smoke. Capital costs of the current networks exceed $74 billion US per year. Assuming 50% over-provisioning, the wasted capital costs amount to $37 billion per year, and this cost is recurring. The current Internet cannot support machine-to-machine communications required for industrial automation. The current Internet also cannot support ultra-low latency consumer services such as cloud computing, cloud gaming, and e-commerce. The question is, can we add determinism to the Internet? We believe the answer is yes. A convergence should occur. A converged Internet should support both the best effort and deterministic traffic classes. We've done this for highways, where we include an expedited traffic class along with the existing best effort traffic class. To converge, some difficult mathematical problems must be solved. In 2015, the IETF started adding determinism to the Internet as work in progress. It's targeting 50% plus utilizations for deterministic traffic in the future Internet. In 2015, the Industrial Internet Consortium proposed a first draft industrial Internet design. Determinism could help significantly. In 2015, the ITU explores the goals of a low-latency tactile Internet. We believe determinism could help significantly here as well. Our deterministic industrial Internet design achieves A. deterministic communications and B. unrivaled 100% utilizations. By achieving 100% utilizations, our deterministic design can reduce capital costs by potentially $37 billion per year. According to General Electric, industrial automation using the industrial Internet can increase world GDP by about $15 trillion by the year 2030. GE also estimates that industrial automation can control about 50% of world GDP by the year 2030, or about $85 trillion of GDP. Our SDN control plane can create deterministic connections in layers 2 and 3. The Internet network consists of many Internet routers and resides in layer 3, as shown in this figure. Beneath layer 3 is typically an optical transport network which resides in layer 2. The optical transport network consists of much simpler optical packet switches. Our SDN control plane can create thousands of deterministic virtual networks. This slide shows a deterministic virtual network with many links originating at Chicago to every other city, as shown in red. This deterministic virtual network can be used, for example, to deliver highly aggregated video streams from a Netflix server in Chicago to every other city. In fact, each service provider can have its own secure deterministic virtual network. Each virtual network is completely distinct from all other virtual networks. They do not interfere with each other. Our deterministic internet design can reduce end-to-end delays to the speed of light in fiber. Across the USA, end-to-end queuing delays can be less than 10 microseconds, and end-to-end jitter can be less than 10 microseconds. Today, where are deterministic machine-to-machine networks used? They're used in industrial automation and robotic factories, the avionics industry, and NASA spacecraft. Tomorrow, where will deterministic machine-to-machine networks be used? There are many applications: smart cars, smart buildings, industrial automation, smart infrastructure, smart transportation systems. This slide illustrates the use of machine-to-machine communications for robotic manufacturing. This slide illustrates the Airbus 380, which uses a deterministic network called AFDX, which is similar to deterministic Ethernet. This slide shows the NASA Orion spacecraft. It uses a deterministic network called time-triggered Ethernet. This slide shows the existing power grid. One of the key issues moving forward is how to control the future smart power grid, which is distributed over thousands of miles of distance. A deterministic internet would be ideal to control the smart power grid. A deterministic internet network can be used to optimize a distributed windmill farm. Our SDN control plane can achieve queuing delays less than 10 microseconds across the USA. Our SDN control plane can achieve jitters less than 10 microseconds across the USA. In fact, most jitters are less than 1 microsecond, according to this figure. Our SDN control plane can deliver machine-to-machine traffic flows through a network of simple deterministic packet switches. This slide illustrates one of the deterministic packet switches. Deterministic packet switches can be far less expensive than the existing best effort switches and routers used in the Internet. Our deterministic packet switch design can reduce router buffer sizes by a factor of 100,000 times, enabling a significant reduction in cost, complexity, and power use. It also enables the use of optical packet switching. Our deterministic internet demo will deliver 1,024 traffic flows through a simple network of 8 deterministic routers. Packets are generated on the left-hand side, and they're delivered through a linear network of 8 routers to receivers at the right-hand side. Our SDN control plane configures each router with several deterministic schedules that control the movement of packets through each router. Our network can achieve 100% utilization for unrivaled energy efficiency and performance. Our network can create deterministic machine-to-machine connections in the Internet, in data center networks, and in supercomputer networks. Our demo will route 1,024 flows. This slide shows, for example, 4 out of 64 flows that originate at input port 7. This slide shows 32 out of the 64 deterministic flows that originate at input port 7. You can see how heavily loaded the switches are with just the flows coming from input port 7. and there are 16 such input ports. Every switch has a traffic matrix to be scheduled. This slide illustrates a 16 by 16 traffic matrix at switch 4, which needs to be scheduled. At the start of the demo, all deterministic flows have their data at the input side of the network on the left, and each flow has transmitted 0% of its data to the output side, shown on the right. Midway through the demo, all deterministic flows have transmitted 50% of their data with near zero jitter. At the end of the demo, all deterministic flows have transmitted 100% of their data to the output side with near zero jitter. A hardware testbed has been developed on an Altera FPGA board. The testbed transmits over 400 million packets per second. This slide illustrates the effect of aggregation on bursty video traffic. The top graph illustrates a single bursty video flow. The bottom graph illustrates the aggregation of 10,000 copies of the same bursty video flow. Aggregation results in a significant reduction in burstiness and will enable very high link utilizations to be achieved on a core backbone network. In conclusion, we argue that a future converged deterministic Internet should support both the best effort and deterministic communication paradigms. We argue that a speed-of-light deterministic Internet can fundamentally transform virtually all consumer services, including cloud computing, cloud gaming, e-commerce, video distribution, and control of the smart power grid. We argue that a speed-of-light deterministic Internet can move communications forward into the 21st century. This video is based on a paper supporting consumer services in a deterministic industrial Internet core network in the IEEE Communications magazine, June 2016.